All right, so we are going to be looking at homogeneous linear differential equations with constant coefficients, and we are going to look in this video at case number 1. All right, so on case number 1, we're going to be finding distinct real solutions, meaning M1 is not the same as M2. So an example that we have is 2y double prime minus 5y prime minus 3y equals 0. So this is a second order linear, because of the form, differential equation, and each one of my functions of x that are in front of my derivatives of y are all just constants. All right, the auxiliary equation that I can then set up is 2m squared minus 5m minus 3 equals 0. Now, a couple things that I do see students mess up on here is forgetting, or maybe even like taking the y with this, because it feels like you're just replacing the squares and then the 1, and then for some reason the m ends up here, and then we end up doing silly things here. I like to think about it as like you had to factor out that e to the mx part, so you had to almost like factor out that y piece, and then this is what's left over when you do that. So you have 2m squared minus 5m minus 3. We now need to factor this. So I know that 2m and m must be my leading terms, because those are the only two things that would multiply to m squared. And then I need to figure out factors of 3, one positive, one negative, so that when I multiply by 2, I get negative 5. That's going to happen if I put a negative 3 here and a positive 1 here. That's going to give me negative 6m plus 1 gives me negative 5m in the middle. All right, each one of these pieces I set equal to 0. And so one of my solutions for this is going to be m equals negative 1/2. The other solution is 3. Therefore, we can write our general solution using the superposition principle, that both of these are going to work, and they are not linear combinations of the other one because their exponents are different. So I don't need to worry about these being linearly dependent. That's going to be my solution for this second order differential equation. Remember, you can always check it by then taking the first and second derivative, plugging it in, and making sure that you were correct.